Welcome back to the physics class, my dear students. So in the previous class we all discussed regarding some numericals which comes under the motion in a straight line chapter. So dear students, accordingly, so after the completion of the motion in a straight line, so now we are moving towards the next chapter, that is motion in a plane. Dear students, while discussing the first chapter, that is motion in a straight line, even I just explained what is one-dimensional motion, what is two-dimensional motion, and also what is three-dimensional motion. I said you that the one-dimensional motion, right? So one-dimensional motion exactly deals with the straight line motion, and the two-dimensional motion deals with the planar motion, and the three-dimensional motion deals with the space. So dear students, motion in a plane exactly indicates that the object is moving in two dimensions. That is, object is moving in any two rectangular coordinates, that is xy or yz or zx axis. To study in detail about the concepts which comes under this motion in a straight line, motion in a plane, so we should know first what is scalar and vector. Dear students, even I discussed the definition and also the difference between the scalar and vector in the previous class. And while discussing the first chapter, I just explained you all such things. Now let us move towards how many types of vectors are there and how to represent the vector and all. Dear students, you know that scalar quantity is the one, and wait, scalar quantity is the one which is having only the magnitude, but it is not having any direction. So what is the magnitude? It is magnitude is a numerical value. So ಏನು numerical value ಅಂದ್ರೆ so ಏನು examples ನ ಕೊಡಬಹುದು. So we can give a lot of examples for this. So the lot of examples like the distance is a scalar quantity, speed is a scalar quantity, mass is a scalar quantity. So likewise, even we can define a vector quantities also. What is a vector quantity? The physical quantity which is having both the physical quantity which is having both magnitude and direction. Is called vector quantity. So then, my dear students, how to represent a vector? Quantity. Dear students, the vector quantity is represented by, see, I am just moving towards the representation of a vector quantity. See, representation of vector quantity. So that the vector quantity is represented by arrow mark, right? So that the vector quantity, so always while writing any vector quantities, my dear students, we should represent whether it may be the velocity, whether it may be the force, whether it may be the acceleration, always it is represented by an arrow line. So that the vector quantity is represented by the arrow line. Yes, it is represented by the arrow line. So then, in that, if I just write the arrow line in this way, see, I am going to write the arrow line, here I am writing it. So, see, my dear students, so this arrow line is a representation of a vector. Then in this arrow line, we have a straight line as well as an arrow mark. The straight line indicates, the straight line gives you the magnitude, because the vector quantities are in both magnitude and direction. as well as the arrow mark. Arrow indicates the direction of the vector quantity. The direction of the vector quantity. Okay then, how to write that. See my dear students, while representing this vector, it is written as OA. OA, above that OA, I'm just writing vector symbol. This is the representation of this vector. Right? See, if I want to write only the magnitude, I want to write in this way. This is a vector quantity which represents the direction. This is a vector quantity which represents the magnitude. This is how to write the vector quantity. Dear students, here and this arrow mark, so that this is said to be the origin, where it is said to be the tail of the vector. Origin point, or it is a tail, and this is said to be the head. Right. The arrow starts at the tail and ends at the head. So that the arrow mark, the vector is represented by an arrow mark which is having tail and head. Whereas the arrow mark starts moving from, so it means that the tail is a point where exactly the object is going to start its journey, and head is a point where exactly it is going to end. That is only for representing the distance. Distance represents magnitude. So vector quantity is having the tail and end. The origin point of the vector quantity is called as the tail, and the end point or the terminal point of the vector quantity is called as edge. I am repeating again. The origin point of the vector quantity is called as tail, and the terminal point of the vector quantity is called as edge. Hope you note it down. So don't forget to take down the notes, dear students. Okay, so this is about the definition and also the representation of vector. So then, why is there need to study about these vectors? So is there need to discuss the vector quantity? Yes, obviously, because the vector quantities is having their own importance. So let us discuss the importance of the vector quantity. Importance of the vector quantity. So here the vector quantity gives you the position. Vector gives the position of a particle, and also vector gives the direction of a particle. So it means the vector gives the position of any object or any particle, as well as even it gives the direction also. Not only that, even many laws in the physics can be easily discussed with the help of this vector concept. See my dear students, when we come towards this vector is divided into so many types. So vector is divided into so many types. So that first I am going to discuss. Let us move towards the discussion of types of vectors. Right? Yes. Let us discuss the types of vectors. Dear students, when we come towards the discussion of types of vectors, first I am going to discuss with unit vector. So what is this unit vector? Unit vector, see here, the vector with unit magnitude is called unit vector. Keep in your mind, the vector with unit magnitude is called unit vector. See, it means the magnitude of this vector, magnitude of any vector is equal to 1. Suppose if I consider that I have a vector A, so that this is said to be unit vector when when the magnitude of this vector is equal to 1. See, I am representing, magnitude is represented in this way. We have this vector, so we have a vector by the name A. But this vector is having a magnitude is equal to 1. So that kind of vector is said to be the unit vector. Dear students, then I can easily say that the unit vector is represented by unit vector is represented as n cap. What is this? Here I am pronouncing it as n cap. It represents the unit vector. Dear students, unit vector gives the direction. Unit vector gives the direction of the particular vector. So it gives the direction. Unit vector gives the direction. So how, in which direction it is moving? Whether it is moving in x, whether it is moving in y, or whether it is moving in z axis. Dear students, suppose if I want to write a vector, I said you that if I consider that A is a vector, always the vector is represented with an arrow head. So if you want to write some other vector like velocity vector, because velocity is a vector, so write it as V vector. And if you want to write acceleration, because acceleration is a vector quantity, put arrow mark over the acceleration symbol. Suppose if you want to write the force, because force is a vector quantity, so just write an arrow head above the letter F. So in this way, I am just going to consider a simple vector said to be A, whereas that vector is written as A arrow mark. So that here this gives a vector, so this can be written as, this vector is having both magnitude and also direction. I said you that the direction is given by the unit vector, whereas the magnitude of this vector can be written as, in this way already I shown you, this is a magnitude. So the vector is having magnitude as well as direction. See, even you can write this in this way also, overall, even you can represent in this way. So A is a vector, whereas this vector is having both magnitude as well as direction. So that the magnitude of a vector A is this, as well as the direction of the vector is written as A cap. No issues. If you represent it by n cap, good. If you represent it by A cap, that's good. Now, this is the representation. Now, how to write the formula for vector, unit vector. Unit vector is written as n cap, which is equal to vector A divided by magnitude of vector A. What I did, I just shift this magnitude towards this side. So I got in this way. That is what vector A divided by magnitude of vector A. So this is a formula for unit vector. See dear students, both are the same physical quantities. Both are same vector quantities which are present in the numerator and denominator. So I can say that the unit vector is a dimensionless. Unit vector is dimensionless, and with no unit. It means there is no SI unit for the unit vector. There is no dimension for unit vector. Then suppose these are all the points related to the unit vector. Suppose if I want to represent the unit vector along coordinate axis, then how to write those unit vectors? Dear students, so you can write down the diagram also, so that I am writing the rectangular coordinate system here. So this is said to be the rectangular coordinate system, so which is having x-axis, y-axis, origin and z. Right. See my dear students, the direction of any vector the direction of any vector. Assume that an object is moving from one point to another point, so that the position of that object in a plane, the position of an object, see that object was moving, right? So object is moving. How to represent the position? Assume that the object is here, that is said to be point P. Then the position of this can be written with the help of mathematics, that is x comma y, right? Okay, then this is a vector, right? So I just want to represent here it with arrow mark, so that the tile starts from the origin of the rectangular axis and the head of the vector ends at the point P, that is at the position. Now the unit vector along x-axis is I cap, so this is fixed, whereas the unit vector along the y-axis is j cap and the unit vector along the z-axis is k cap. Keep in your mind, the unit vector along x-axis is I cap and along y-axis is j cap and along the z-axis is taken as k cap. So these are all the unit vectors. Now let us move on with the discussion, so which gives another different types of vectors. So here we just discussed regarding the unit vector. Now let us move towards the discussion of zero vector, or even it is called as null vector. What is zero vector? It is even easily defined as the vector with zero magnitude is called zero vector. Is called zero vector. How to represent the zero vector, dear students? So the representation of a zero vector is very easy. So even you can call the zero vector as null vector also. So the zero vector is represented in this way. Keep in your mind, this is zero representation of zero vector. So my dear students, there are some properties of zero vectors. There are some properties of zero vector. So that if you add the zero vector to a scalar, what happens? Suppose if you add a zero vector, what happens? See, adding of a vector with a zero vector always gives you a vector quantity. This is one of the vector quantity. This is said to be the zero quantity. Addition of zero vector with any other vector gives you always a vector quantity itself. Similarly, if you just subtract a zero vector from any vector, suppose if you subtract zero vector from any vector, again it gives you the same vector itself. And even if you add or even if you multiply, see here I am just multiplying a vector with a zero vector, it gives again a zero vector itself. And if you add any scalar, see scalar means it is having only magnitude. You can take k or you can take lambda. So this is a scalar, so I should not write the arrow mark. If I write the arrow mark, it becomes vector quantity. So if I write the arrow mark above this symbol, it becomes a vector quantity. So that I should not represent it in this way. Because if I just add a scalar quantity with zero vector, I will get again the same scalar quantity. These are the properties of zero vector, dear students. Hope you all written. So now let us move with the next vector, that is said to be parallel vectors. Anti-parallel vectors. See, parallel vector. See, dear students, these vectors, see here, when we consider the parallel vectors, suppose first before defining it, I will just write the diagram, then you will get an idea to define by yourself. If I just write the vectors in this way, assume that this is a vector A and this is said to be the vector B. I have the two vectors A and B. So you can observe it on the board, whereas both the vectors, that is what the vectors which are having the angle between them which is equal to 0. The angle between these two vectors are equal to 0. The vectors, these are the vectors which are having these are the vectors which are having zero angle between them. So the angle between A and B is 0. So that is what the vector A and vector B are having the direction as well as it is having the magnitude. But we don't know whether both are having the same magnitude or both are having the same direction. We are not bothering about that. We are just bothering about whether what is the angle between these two vectors. The angle between the two vectors is said to be 0. Then it is said to be the parallel vectors. Similarly, we have another type of vector, that is anti-parallel vector. Anti-parallel vector. Dear students, see here, if I write it in this way, that is what? You can observe one vector is moving in one direction, whereas another vector is moving in opposite direction. So then you know that if one is in this way, if one is moving in this way and another vector is in this way, then what happens? The angle between them is equal to 180 degree, right? So I can say that the anti-parallel vectors are the vectors which are having a 180 degree angle between them, That is said to be the anti-parallel vectors. Now let us see what is equal vectors. So I am just defining the vectors here. Equal vectors. Yes. What is equal vector? See dear students, you can observe carefully that I am writing two vectors here, vector A and vector B. Whereas the magnitude of vector A should be equal to the magnitude of vector B. Direction of vector A should be the same of direction of vector B. So then the vectors are said to be equal when they are having both magnitude and direction are same. So the vectors with same, the vectors with same magnitude. It means they should have the same value of the magnitude and they should move in the same direction. So that kind of vectors are called as equal vectors. So those kind of vectors are called as equal vectors. And dear students, we have other two types of vectors said to be like and unlike vectors. So whereas don't confuse with parallel, equal, like and unlike. So like vectors are there and another one is unlike vectors. Now I am discussing with like vector, right? What are like vectors? See, you are not going to bother about the direction. You are not going to bother about the magnitude. We are going to bother about only the direction. If the vectors which are moving in the same direction, the vectors with same direction, which are moving in the same direction is called as like vectors, right? So you can observe here the magnitude of A is different compared to that of the magnitude of B. And this defining the like vectors, we are not moving towards the consideration of what exactly the magnitude is going to happen here. We are considering the direction only, so that the direction of both the vectors are same. If the direction of the two vectors are same, then those vectors are called as like vectors. Suppose if the two vectors we have, whereas both are having the different magnitude, so represent the diagram also in your notebook. So you can observe the A vector is moving in x direction, B vector is moving in minus x direction. So this indicates that the vectors with opposite direction, moving with opposite direction, it is called as unlike vectors. This is called as unlike vector. Hope you got, dear students. So with this, even we have some other vectors like co-initial vectors and co-terminal vectors. So these are enough to just to know about the types of vectors. Still we have some more vectors, that is to be the co-initial vectors. So co-initial vectors. So what is this co-initial vector? Even I can define it. Suppose if the two or more vectors are originating from the same point. So if the two or more vectors, let us say this as a vector A, this as a vector B, and this as a vector C. So this is O. Whereas if two or more vectors are having the same initial point, so that those kinds of vectors are called as co-initial vectors. So as well as even we have another one type, that is co-terminal vectors. Co-terminal vectors. If the vectors, if two or more vectors, if the two or more vectors are having same terminal point. If the two or more vectors, write down the definition. If the two or more vectors are having the same terminal point, let us say A vector, B vector and C vector are having the same terminal points. This is said to be the terminal point. So that is said to be the co-terminal vectors. Even we can define the co-initial vector in this way. If the vectors, if two or more vectors are originating from the same point, that is said to be co-initial vector. If two or more vectors are going to meet, are going to terminate, are going to end at a point, that is said to be the co-terminal vectors. This is about the types of vectors, dear students. So after knowing this types of vectors, let us move towards adding of the vector. So we can add the vectors. So let us move towards the discussion of addition of vectors. Let us move towards the discussion of addition of vectors. Yes. When we come towards addition of vectors, my dear students, so that there are two different laws of addition. One is triangle law of vector addition, and the next one is parallelogram law of vector addition. First, I am moving with the first law, that is triangle law of vector addition. Yes, I am just going to add two or more vectors. Hope you are all with your book. So take down the heading that addition of vectors, and also let us move towards the subtraction of vectors and also multiplication of vectors in the next class. But now let us see the triangle law of vector addition and also see what is exactly the parallelogram law of vector addition. Dear students, when we come towards the discussion of triangle law of vector addition, first we should know what is a statement of this triangle law of vector addition. So what is the statement of triangle law of vector addition? Yes. First, let us move with the statement and let us explain it. So I will just dictate you the statement, so you can write the statement by yourself by the time and I am going to dictate it. Yes. Dear student, you can observe that triangle exactly shows you that we are going to represent the vectors in a triangle form. So dear students, I am just considering if the two vectors, if the two vectors represented by both magnitude and direction along the two sides of a triangle in the same order, then you can see here I have the two vectors. So this is said to be two vectors A and B. So I am just writing it here. If two vectors both magnitude and direction is represented by the two sides of triangle in the same order. in same order, then the resultant vector is along the closing side of the triangle in an opposite direction. Yes, this is a statement of triangle law of vector addition. So then, with this statement, we can observe we have the two vectors here. If the two vectors, so those two vectors are having both magnitude and direction. So for writing of the diagram, I am just going to consider the two vectors here. I am just going to consider the two vectors. Let us say the vector A. It is having magnitude and direction. As well as let us consider another random vector that is said to be B. So those two vectors are having magnitude and direction. So now here I am just going to write it clearly. So those two vectors A and B. See here, two vectors both with magnitude and direction is represented by the two sides of a triangle. See here, these two are the sides of triangle, whereas these two vectors are represented along the two sides of triangle. We represented it in the same order. Same order means, so here the vector is going to start from tail and ends at head. After that, at that position itself, the next vector should start. That is said to be the same order. It means if the one vector is like this, other vector should be in this way. So otherwise, if you just write that, at the end of the first vector, I should continue the next vector. That is said to be a same order, one after the other. So that I represented, and then the resultant vector is, what is resultant? Resultant means, here we have the two vectors. See, if I just give you 2 and 3, what you will give? So 2 and 3 is equal to 5. Right, similarly, here we have the two vectors represented along the two sides of the triangle in the same order. Then where is the resultant? Resultant is here. Whereas the resultant is represented along the closing side of the triangle. This is the closing side, right? This is the closing side of the triangle. This is said to be the closing side. So because this is said to be the remaining side of a triangle, it's said to be closing side of a triangle, whereas third closing side of a triangle in opposite direction. See, if I write this in this way, it is in the same order. So, but the resultant should be always in an opposite direction. Whereas the resultant vector is represented by the symbol capital R, that is vector R. Then the resultant vector R is written as vector A plus vector B. This is the triangle law of vector addition. Vector R is equal to vector A plus vector B. Right, dear students? This is a triangle law of vector addition. Now, my dear students, even we can do the same addition of vectors by using a parallelogram law of vector addition. Hope you all written this. Now I am moving towards parallelogram law of vector addition. So I am going to write the first statement first. If the two vectors, both with magnitude and direction, is represented by the two adjacent sides. Represented by the two adjacent sides of parallelogram, right, originating from the same point. So I am going to write here itself, originating from the same point, from the same point, comma, then the resultant vector is along the diagonal of the parallelogram from the same point. So this is a statement of parallelogram law of vector addition. So if the two vectors both having magnitude and direction is represented by two adjacent sides of parallelogram. So first let us write the parallelogram. So here I am going to write the two adjacent sides of the parallelogram, right? So now this is origin. So now two sides of the adjacent sides of a parallelogram originating from same point. It means we have two vectors. So that is said to be vector A and vector B, where they should be represented along the two adjacent sides. Any two adjacent sides of parallelogram. Here it is written along the two adjacent sides of parallelogram. Then here the condition was originating from the same point. It means the two vectors should come from the same point. Easily I can say that those two vectors are co-initial vectors which are having same origin or which are having same origin point. Then where should be the resultant? The resultant vector is along the diagonal of the parallelogram. So diagonal of the parallelogram is in this way, whereas that diagonal should also emerge from the same initial point. So my dear students, so this is what the resultant vector R. This is said to be the resultant vector R. So you can close this. You can close the other two sides of the parallelogram. These two sides are parallel. So due to this parallel sides, this is A, this should also be equal to B, and this is A, this should also be equal to A. So my dear students, the resultant vector R is equal to vector A plus vector B. So finally we represented here vector R can be written as vector A plus vector B. This is about the parallelogram law of vector addition. So we just discussed the two different methods of addition of vectors. So then let us see the subtraction of vector. Subtraction of vector. If I consider that I have the two vectors, vector A and vector B. Suppose if I have two vectors, say it as vector A and vector B. If I want to subtract vector B from vector A, it should be written as vector A minus vector B, and the resultant is written as capital R. That is vector R. Rather than this, even you can define it like adding of vector A and minus vector B is also called as subtraction of vector. So how to write this? A plus of minus B gives you the resultant vector R. So we can write the subtraction of vector in two different ways. So adding of A plus minus B gives you R, or else subtracting B from A gives you the resultant vector R. This is about subtraction of vector. Then dear students, now let us move on of representing the position vector. So before moving towards the representation of a position vector, let us write the diagram which exactly shows you how the subtraction of vector takes place. See here, if I have the vector A is in this way, right? This is a vector A and the vector B as in this direction. According to the triangle law of vector addition, The resultant is along the closing side of a triangle. So whereas vector R can be written as vector A plus vector B. Then how to subtract these vectors? So if I just write the vector in this way, the vector B becomes a minus B. So adding of a vector A with minus B vector gives you the resultant vector R, which is said to be the subtraction of vector. So that this is how to represent the subtraction of vectors. So with the help of triangle law of vector addition. Okay dear students, now let us move towards the next thing, that is said to be the position vector. Okay, then how to define this position vector, dear students? So dear students, here it is, position vector is defined as it is a vector drawn from the origin to the position of a particle at any instant. So let us see how actually to define this. So I am using a coordinate system here. So rectangular coordinate system. Here I am just going to consider the two axes. One is along x axis and another one is y axis. Whereas O is said to be the origin. Dear students, what is a position vector? Assume that the particle is moving, so that the particle is having a different positions here. So at some time the position of a particle is here, and at some time the position of a particle is here, and after some time the position of a particle is here. So at every instant of time the position of the particle is going to vary. So I am going to represent the position of a particle by P. According to mathematics, the position of a particle is represented by x, y. So then, what is a position vector? It is just a vector drawn from origin. So from here we should draw, right? From the origin we should draw. So to where we are going to draw? To the point where the position of a particle is going to present at that particular instant. So this is said to be the position vector. Position vector is represented by the symbol small r. So that dear students, OP can be written as vector R. OP can be written as vector R. It means, dear students, vector R is a position vector, whereas this position vector represents the position of a particle, as well as position vector represents in which direction the particle is moving, and also the position vector gives the straight line which was connecting between the origin and the position of that particular point of the particular object. So dear students, here I just shown you the representation of this position vector is R vector. How to write this R vector? We can write this in a different way. See here, along x-axis we have unit vector I cap, and along y-axis we have unit vector j cap. Then I am just repeating again. Position vector gives you the position of a particle, as well as it gives you the direction of a particle in which it was moving, and also finally it gives you the straight line which connects between the straight line connecting between origin and the position of a particle, right? So then how to represent this R? Here we have x and y, right? So then the position of particle can be written as x plus y, means vector x plus vector y. My dear students, rather than writing this in this way, why? Because there I am just writing it as a vector. I should show the direction as well as the magnitude for this position vector. Along x-axis, we have the unit vector I cap plus y j cap. So this is a representation of position vector. Position vector is represented as xi cap plus yj cap. X is a magnitude and I is a unit vector along x direction and y is a magnitude and j is the direction along y direction. Totally gives the position vector of a particle which is moving in a plane. Then how to write this r magnitude? So it can be written as r is equal to x square plus y square. See, I am just saying again, the magnitude of r can be written as square root of x square plus r square. So dear students, this is about the position vector. This is about today's class. Almost all we discussed the types of vectors and also we discussed the two laws of vector addition, subtraction of vector and also finally the position vector. Thank you. Or don't forget to write the notes.